Okay, so today is a special day. I'm going to send this. So it's actually my sister's birthday. Say happy birthday, Sue Ann.
Happy birthday, Sue Ann.
Okay, I'm going to send her that video so she sees that. She won't care about the rest of the video. So anyway, I can't remember how old she is, but happy birthday. The other weird thing about today is, well, normally you have to turn in your taxes on April 15th. Is there anybody that has not turned them in? I mailed mine this morning. Mine was 16 pages. It's awful. But I actually got engaged on tax day, which was actually April 15th, 2 days ago. 18 years ago. So it's like, you know, it's kind of one of those bittersweet days, you know. That was the sweet part. The paying the taxes today was the bitter part. But anyway. All right. So 13.2 is what we call the post-hoc ANOVA / Tukey test. Okay? So that's what we're going to do about this. So the idea here is, this is really a continuation of yesterday's lecture. Tukey, you know, like turkey only without the R. Tukey test. Okay? So the idea here is you've just come up with your conclusion that at least one mean is different. And now we want to figure out which mean is different. Okay, so that's where Tukey comes in. Okay, so we're going to assume that x1 bar is greater than x2 bar, which means we're really going to need to sort our means in descending order. And we'll talk about that in just a minute more. Okay? Now, we're also going to find our critical value. Okay? And because I didn't want to use T for Tukey, we already got T for T distribution, we use the letter Q. Tukey sounds like a Q, I guess. I don't know why. Anyway, you've got alpha, V, and K. So alpha is your significance level, just as we always use. V equals n minus K, and K equals K equals the number of means. Okay? So I'm going to talk more about that in just a minute. And so let's talk about the steps that we want to follow. Okay, so as I mentioned previously, you want to sort your means in descending order. Okay, now you don't have to do that, but it sure makes your life a whole lot easier if you do. Okay?
K is number of means, right?
K is your number of means, that's correct.
V equals n minus k.
V is in Victor equals n minus k. Okay? Step 2 is you're going to compare your pairwise differences. Step 3, this is the big key here, you're going to compute the value Q sub 0 equals x1 bar minus x2 bar divided by the square root of s squared over 2 times 1 over n1 plus 1 over n2. So that's our new equation today that we need to know. All right, step 4 is to find the critical value, and I'll show you how to do that in just a minute. Step 5 is to reject the null if Q0 is greater than Q. And step 6 is repeat for all pairs. What did you say?
The variance divided by 2.
S squared. That was the next question I was just going to answer. She's right on where we're just like this. Okay. All right. So S squared. What is S squared? S squared is actually the MSE that you found previously when you did your ANOVA test. Okay? So that MSE is super important. Okay? Now, we're going to jump in here as if we've just done our ANOVA test. We've concluded that all the means are different. But here, let me just mention this really quickly. On the final exam, you're going to have an ANOVA test. Probably doesn't come as a shock to you, does it? Okay? I don't want to give away so normally, if you had the conclusion that the means were not significantly different, you wouldn't need to do a Tukey test. If that's your conclusion on the final, I still want you to do the Tukey test. It will still tell you that none of the means are different, but I don't want to give away the answer. Does that make sense? So do the Tukey test no matter what on the final. Normally, you'd only do it if you got this conclusion, though. Okay? All right. So let's do an example. Go ahead and let's open up our worksheets here. At the bottom, in-class worksheets. And we're going to go to 13.2. I've got the correct one there. We'll just open up the blank one for now, though. But you can see the correct one. That's so I don't have to post it again later. Okay? All right. So here is our worksheet. Okay, so the idea here is we've just done our ANOVA test, and we know that the means are, that at least one of the means are different. Slide that over a little bit. Okay. So the first step is sort your means in descending order. It says ascending there. It doesn't matter whether you do ascending or descending. I don't know why I put ascending there, but descending is probably a little bit better, but it doesn't matter too much. But I'll change that here. As long as they're in order, that's the main thing. Okay? Now, we're going to compare all the pairwise differences. Now, in this case, I've got 4 means. Okay? So the idea here is I'm going to do the pairs. Okay? So I'm going to do the Sillistor minus the cojet. And then I'm going to do the Sillistor minus the ceramic. And then I'm going to do the Sillistor minus the Samara. Then I'm going to do the cojet minus the ceramic. And I'm going to do this cojet minus the Samara. And then I'm going to do the ceramic minus the Samara. Okay? So you'll probably want to do that right first so that you know. So I've got four means. That means I'm going to have to do this 6 times. Okay? We're comparing them all in descending order. Does that make sense? So that's why sorting it makes your life a whole lot easier. So you can kind of get this in a nice pattern going on. Does that make sense? Yes.
How did you sort it?
Sort it in descending order. Just, well, there's 2 ways you can do it. If you highlight the second column first, and then do the first column, you can click on data, and then you can sort it from Z to A, or A to Z. Or you can just, if you highlight it this way, you just go to data, and then you say sort, and you say you want it by the mean, largest to smallest. That works too. Okay? All right, so we've got our pairs now. Now we're going to step 3. Now it's probably going to be easier to do the numerator and do the denominator. Okay? So in this case, we're going to do this the numerator, and just like I've written the pair, we're going to do the Sillistor minus the cojet. We're going to do the Sillistor minus the ceramic. We're going to do the Sillistor minus the Samara. We're going to do the cojet minus the ceramic. We're going to do the cojet minus the Samara. And we're going to do the ceramic minus the Samara. Okay? So I've just done all of my numerators here. Now your denominators, your ends don't have to be the same. We're lucky in that they are. So that means all of our denominators are going to be the same, but that's not always true. Yes?
The CI minus CIN, is that supposed to be CE?
CE, yes. No, let me see. Oh, that's the CO. CO. That's the cojet minus the Samara. Okay? All right, for your denominator, okay, your denominator is going to be the square root of. Now, the s squared, it was 8.835. You don't have to square that again. It's already squared. Okay? So that's going to be 8.835 divided by 2 times 1 divided by, now it says I've got n equals 5, which is really handy, plus 1 over 5. Now, those don't have to be the same, but since they are, all of your denominators are going to be exactly the same. Does that make sense? Okay? So be careful here. The denominator is not always the same, but in our case it is. So I'll just copy that down.
Unknown caller.
Oh my gosh, leave me alone. All right, so now we're going to find our Q naught in this case. Equals the numerator divided by the denominator. So we'll do that for all of them. Okay. Now we're going to compare our critical value. Okay, so this is where we've got a new table for you. Now, unfortunately, I wish there was a Tukey command, but there isn't. Okay? So you're going to have to use the table on here. So I've got a table here called the Tukey table. Okay, so here's your Tukey table. Now, as we look at this, okay, I've got alpha is 0.05 on page 1. It's also 0.05 on page 2. Alpha equals 0.01 on page 3. Alpha equals 0.01 on page 4. Okay? So just pay attention. So we'll use the alpha 0.05 just like we normally would when it's not specified. Okay, so now we need to find V. V equals n minus k. So let's think about this for a minute. If I've got 5 in every sample, and I've got 4 samples, what's my total n? 20. Minus how many samples? 20 minus 4 is going to be 16. Okay, so we're looking over here. We've got the V down here, we're at 16. Okay, and then K is your number of samples. I've got 4 samples. So I'm looking at the combination of 16 and 4. That gives me 4.046. Does that make sense?
So this is different change if you had different things. In this situation, they're all the same.
Your critical value will be the same for all of them. Okay? We're comparing all of these to 4.046. So that will always, your critical value will not change on the problem.
Even if they're inside.
Your denominator might change if your n's are different, but your critical value will not change. Okay? Okay, so we're going to reject if Q naught is greater than Q. Maybe I'll write it this way. If Q naught is greater than Q, reject. Okay? Is 1 greater than 4? Do not reject. Is 5 greater than 4? Yes, reject. Is 5 greater than 4? Yes, it is. Reject. How about 4.13? Is that greater? Reject. 4.24? Reject. And 0.1? Do not reject. Okay? All right, so let's look at this. Essentially what we're saying here is, as we look at this, wow, I'm done earlier then. Okay, so we're comparing the Sillistor and the cojet, okay? Comparing those two. We're saying do not reject. We're saying that those are not significantly different. And those are pretty close together. Now we're comparing the Sillistor versus the ceramic. 17 versus 10. We're saying reject. Those are significantly different. The 17 versus the 10 also significantly different. Now, let's look down here. Ceramic, so basically, here's what we're kind of saying. Those two are not significantly different. Those two are not significantly those two are significantly different than those two.
How do you know if they're significantly different?
They're more than 0.046.
So the idea here is under your null hypothesis with Tukey, these two are different. We're not rejecting that, so we're saying those two are not significantly different.
So they're significantly different if the difference between them is greater than the critical value.
Correct. Okay. So those two are not significantly different. Those two are not significantly different, but cojet is significantly different from some. And all of these little combinations are. Yes.
So when we're doing the critical value, B is equal to n minus k. So if the sample sizes are different, then which one
Yeah,
do we
so-
choose for n?
If you wanted to do this, in fact, we'll throw a wrinkle here. Let's make your n is 5, 6, 7, 8. Okay. So what's your total n in this case? Your total n is going to be the sum of these four here. Okay, which would be 26 in this case. So if we were doing it this, now our n has changed. Okay, our n has changed, but we've still got 4 means, right? 26 minus 4 would be 22. So in this case, our critical value is going to be 22, which is now on. Oh, oh, we don't have 22. Well, that's so we'll have to go with the closer one. That one looks closer. I'll probably go with that one. Should have picked a better one. But anyway, 22 and 4. So I'd probably go with about 3.958. Okay. So in this case, I'm still going to go 3.958 for all of these. These haven't changed. Okay. Now let's go to here. This is where it gets a little bit dicey because now I can't, excuse me, here. Now the first one, here's what I'm going to say. We're comparing the n of the Sillistor plus the n of the cojet. Okay. In this case, we're comparing the n of the Sillistor plus the n of the ceramic. This one we're comparing the n of the Sillistor plus the n of the Samara. This one we're comparing cojet. So this is, oops, this is not going to be 5 anymore. It's going to be 6, and this one's going to be 7. This one's going to be 6 and 8, and this one's going to be 7 and 8. Now I would probably have to go through all this again. Okay. 1 greater than 3.9. Do not reject. 5, that would be a reject. That would be a reject. That would be a reject. And that would be a reject. And that would be a do not reject. So nothing really changed there. But
So the null hypothesis for
the null hypothesis is
and the alternative.
mu1 equals mu2, but of course that's going to change for everything. And then the alternative is going to be mu1 is greater than mu2 because we're sorting this so that x1 bar is always greater than x2 bar. So it's always going to be one tail. Okay.
What are we comparing? What's the Q0 and Q?
Q0 is this equation right here that you're figuring out. Q is your critical value that you're going to pull off the chart.
Okay, go off the charts. Okay.
Yeah.
So is our answer this 2 correct, or do we need to do
So you should say that, yeah, that's a good question. So you would say that Sillistor is not significantly different than cojet, and ceramic is not significantly different than Samara, But Sillastor is significantly different than both ceramic and Samara, et cetera, et cetera. I won't do them all, but okay. All right, so that's already posted up there. You can check out the other one. Quiz tomorrow. I don't know. We'll see. It could be. I don't know if we'll do this on the computer paper. Be prepared either way. All right. See y'all tomorrow.